Hello everyone, good evening. Welcome to Wallah English YouTube channel. I hope everyone is doing great. So till last class we have covered some topics of precipitation. We are going to proceed further. Before starting, everyone kindly comment that I am fully audible and visible to you all. Then we'll proceed. Okay. First we will have a quick recap of what we have learned till now. After that we'll proceed with the new topics. Okay. Basically in today's class, we will try to cover average depth of precipitation and DAD curve. Okay, very important topics. Average depth of precipitation is very important topic. I will try to solve as many as conventional questions as possible in this very class. Okay, and I will request you all to join it and also participate in it, also solve while I am also solving. Okay, so you have to participate in this because average depth of precipitation questions has been framed in previous past year papers many a times. Okay, so perfect. Good evening dear, good evening Vishal, Manjusha, everyone who has joined the session. Good evening everyone. Okay, so first let us take a quick recap of what we have learned till now. So basically till now we have covered, see, initially I told you about water budget, water cycle. Okay, I hope you all know it. Global water distribution we talked of. Okay, how much water is present in ice caps, in lakes, okay, in oceans, that we have discussed already. Then water cycle I told you. Then I told you that sun was the driving force behind it. Yes or no, behind the water cycle, I told you. So that we have discussed. Then we went on to water budget, what is catchment leakage. Okay, based on water budget we have solved many questions. Water budget equation is very important. Okay, I told you about this. After water budget equation, then we went on to residence time. I told you about more the volume, more is the residence time of water in that hydrological phase. Okay, after this we went on to precipitation. In precipitation chapter, sir, basically sir you told us about like what are the causes. Okay, basically sir, two causes were there: when moisture is increasing in the atmosphere, and secondly when temperature goes down. Okay, so these were the two causes which we have discussed. After causes, sir, we went on to types of precipitation. Basically sir, you told us about four types. Okay, the very first one was convective precipitation, because you can see there is a difference in density of air masses. After convective we have orographic, then cyclonic, and then frontal. I hope you remember all the four types of precipitation which generally takes place. Okay, perfect. Okay, perfect. Then after this types we covered forms of precipitation. Okay, we covered rain, snow, sleet, drizzle. Okay, all these things. After this forms of precipitation, sir, we went on to data. Okay, rainfall data was there and it should be continuous and consistent. Okay, then we discussed measurement of rain gauge. Okay, measurement of precipitation, which is done with the help of rain gauge. Two types of rain gauges we discussed. Okay, recording and non-recording. Okay, I will take the doubt, don't worry, I will take the doubt. Rain gauge I told you. After rain gauge, sir, you told us about natural siphon, which is the standard recording rain gauge of India, and your Simon rain gauge, which is the standard non-recording rain gauge of India. Okay, that you have to remember. After rain gauge, sir, we went on to data which would be continuous and constant. Then you told us about normal precipitation. Then you told us about average annual rainfall of India. Can you comment down what is the average annual rainfall of India? Okay, one doubt is there. That in previous lecture about double mass curve, if we are plotting cumulative values in latest chronological order, it will decrease downward now. Okay, yes, you are right. But one thing, I have made a mistake there, but no issues. I will get it corrected. I will tell you. See, what you have to do. See, I wrote down the values starting from 2011 to 2022. Okay, Manjusha, I hope this is clear. See, I told you to plot the values from latest chronological order, which means that this year will be at first. Okay, you have to write 2022 first, then 2021, and so on so forth. You have to decrease it. Okay, so the latest year will be plotted first. Okay, so this mistake I have done there, but if you will reverse it, then I hope it will be very clear to you. Okay, Manjusha, is your doubt clear that I have done wrong? Okay, because I was more focused on explaining the method, but yes, you are absolutely correct, and hats off to you. You have seen such a minute point here. Okay, Basically we draw the graph and the tables starting from latest year. Okay, that I have already mentioned, no issues. Only in the graph, only in the table, what you have to do, you have to write the latest year first. Okay, then your graph will go like likewise, which I have told you. Okay, so this was a little mistake, not a very big one, but yes, you have seen it. Great. So I hope the doubt is clear. Okay, so then also it will decrease. Yes, then also it will decrease. No, then it will increase, because when you will plot the 2022 data first, it will be smaller value. Then 2021 will be more value, will give you more value, because cumulative order is there. That's why graph will go up. Okay, I hope it is clear to you. Then we went on to estimation of missing data. Okay, after missing data, in missing data, sir, you told us about two methods. The very first one was your arithmetic mean method. Okay, in this, what we did, we simply took the arithmetic mean of the values which are given to us. But yes, one condition was there. Sir, what was that condition? Condition was that first we have to take plus minus 10%, and we have to check whether other normal stations, okay, selected stations, are lying within the 10% range or not. Okay, this we have to ensure. If they are coming within the range, then what I will apply? Kindly comment everyone. Then I will apply arithmetic mean. But if even single normal value, if even single normal value is lying outside this 10% range, then what I will do? Yes or no? Then what I will do? Then what I will use normal ratio method. Okay, then I will use normal ratio method. So normal ratio method is simply arithmetic mean of normal ratios. Okay, here we have taken arithmetic mean of normal ratios of station ABC, or simply you can say the selected stations. Okay, this is very important because questions have been framed in examination. I have also given you one question for homework. I hope you have solved it. If not, we'll take it up first and then we'll proceed. Okay, then we went on to inconsistency. Tell me the name of the technique with the help of which we will remove the inconsistency. The technique is known as double mask curve. You have to remember it. It is very, very important. The name is important. The method and all this thing is not that important. Okay, we will correct this. Here what we have to do, we have to take it in latest chronological order. The latest year will be taken first. This I have done wrong by mistake. Okay, latest year first, and then in the reverse order, then you will see that values will increase and the graph will be like this. Then like this we correct it. Okay, not so important, but simply remember that this is your double mask curve. After this we went on to presentation of data. We discussed mask curve. I hope you remember it. Mask curve is very, very important. Okay, mask curve. Can you tell me the two instruments which give you a mask curve? Can you name those two rain gauges immediately? Kindly comment everyone. Can you name those two rain gauges which give you mask curve? See, all these are questions. See, you have to pay attention. All these minute details you have to remember so that everything is fully clear to you all. Kindly comment everyone. Can you tell me the name of those two instruments which give you mask curve? Mask curve, the very first one. Then graph is there, intensity versus time graph. Okay, rainfall intensity versus time. Yes, Vishal, very good. Weighing bucket is there, and the next one is natural siphon. Okay, in weighing bucket and natural siphon, both gives you mass curve. Okay, weighing bucket basically also measures your snowfall. Then hydrograph is there. Hydrograph measures your rainfall intensity versus time. This hydrograph is plotted by tipping bucket. Okay, then we discussed moving average method, in which it gives you trend of rainfall and smoothness of the fluctuation. I hope it is very, very clear to you. Then we solved some questions. I hope you remember these questions. Okay. Okay, so in today's lecture, we are going to cover average depth of precipitation, but before starting, we will solve this question. Okay, so I hope you have solved it. We will solve this question very quickly. So what this question is saying, the normal annual precipitation of 5 rain gauges of PQRST respectively are this. Okay, so it is saying PQRST, 5 stations are there, and their normal values are simply given to you. Okay, n values are simply given to you. Okay, so let us write those n values. So it is 125, 102, it is 125, 102, 76, 113, 137. Okay, these are the normal precipitation values. During a particular storm, the precipitation recorded by PQRS. Okay, So values are given to us 13.2, 9.2, like this, 6.8, then 10.2, and the instrument at station T was inoperative. So this is missing. Okay, you will simply solve it and find the rainfall at station T, during that storm. Okay, so for a particular storm. Now tell me if we will apply normal ratio, or tell me if we will apply normal ratio or arithmetic mean, which method we will apply here? Can you tell me? So first what we have to do, the normal of missing value. Okay, the normal precipitation of the station in which data is missing in this very year or whatever storm there is. Okay, so we will do what? First I will take 137. First decrease this value by 10%. Yes or no? Tell me how much it is coming. See, take out your calculators and try all these questions. Okay, you have to be very participatory in class, otherwise nothing you can recall later. Okay, try to be participatory here so that each and every concept is clear to you. See, if you are giving 1 or 1.5 hour in the class, try to make sure, okay, or ensure that everything is covered in class itself. Okay, all the revision thing, okay, participation part, revision part, question solving, all is covered in this 1.5 hour only. Okay, so how much this is coming, and then increase this value by 10%. Okay, yes, 123.3 and 150.7. Great, Vishal, great. 120 point, how much you are saying? 123.3 and 150.7. So 123.3, 150.7. Great. So now check if all the other normals, at PQRS, normals at P, Q, R and S are lying within this range, within plus minus 10% range, or outside. So if you will see the very first value 125, so 125 is coming in this value. Okay sir, it is correct. Then 102 is not falling in this range. 102 is not falling in this. So if only only one value is not lying inside this range, or if one value is lying outside this range, then I will say we have to apply which method? Can you tell me? Can you tell me which method we have to apply here? Which method will apply? Kindly comment, then I will proceed. You have to tell me which method we have to apply here. Tell me everyone. Which method we have to apply? Perfect. We have to apply normal ratio method. Great. So what is my normal ratio method? Because one value has gone outside. Even if single value goes outside, then I will apply normal ratio method. So what I have to do? PT upon NT. PT I have to find. Sir, PT I have to find. NT is given as 137. Is equal to 1 by M. M is what? 4, because here we have 4 working stations. Okay, these 4 are working stations. I hope this is very clear to you. Simple. 4 working stations we have to take average of normal ratios. So PP by NP. Okay, precipitation of P divided by normal. So 13.2 divided by 125. Then the next station is 9.2 upon 102. Then for the next station we have is 6.8 upon 76. Then we have 10.2 upon 113. Okay, so this is your normal ratio method. Kindly tell me how much value you are getting here. Okay, I am waiting. Everyone tell me how much value of PT we are getting here. Yes, perfect. Tell me, Kiran, Vishal, everyone. Kiran, Vishal, Manjusha, Sushil, everyone tell me how much value we are getting here. Okay, the value which we are getting here is, how much we are getting here is 9.2 upon 102. 12.86 you are telling. Okay, let me check if we are getting it as 10.2 divided by 113. 12.86 we are getting. Yes, perfect, Vishal. 12.86 is the answer. Great. We are getting it as 12.86. Okay, so these type of questions you can expect. See, this is a question from your gate examination only. Okay, this question has been asked from gate examination only. So remember this. This is very, very important. So I hope this is very, very clear to you. Now we'll proceed with our next topic, which is none other than average depth of precipitation. See, average depth of precipitation is the one of the most important topics of your precipitation chapter. Okay, see, this is see, many questions have been framed in previous examinations based on your Thyssen polygon method, isohydral method. Okay, arithmetic mean questions they haven't asked, but let us try to understand first, like, why we are interested in finding the average depth. Can you guess it? Can you guess it? Can anyone comment down below, like, why we are interested in finding the average depth? See, one very basic concept is there. Let us suppose we have a catchment area. Let us suppose we have a huge catchment area, and in the center, you all know that we have the lowest line in which your central stream is flowing. Okay, you all know this. So what happens here? Basically, what happens here is, see, these are all your these are all your rain gauges. Okay, we have certain rain gauges, but you should appreciate the fact that all these rain gauges will not measure the same value of rainfall. Yes or no? Do you agree with this? All the rain gauges will not, you can say, measure the same value of rainfall. Yes, sir, that is true. Now listen very carefully. If, and also you should understand that this entire catchment area is not flat. You should appreciate the fact that it is slopy in nature, or you can say it is undulated, or you can say it is uneven. Okay, the topography will be irregular. Yes or no? The topography will be irregular and it will not be perfect. It cannot be perfect. It is rough. It is not flat or plain. Yes or no? So, sir, can you tell me, if I will convert, if I am converting this catchment area into a plane surface, try to understand. Okay, sir, if I am converting this catchment area into a plane surface, if I am converting this catchment area into a, you can say, plane surface, yes, see here, we have converted this catchment area into plane surface, but one thing you have to understand, see, this diagram is not so good. Wait a second. This catchment area is having a area A. See, we have converted this catchment area into plane area. Okay, okay, so you have to understand, see, this is the plane area. See, this area and this area are same, and the depth here is, see, what depth we have to use here. What depth we have to use here? See, firstly, we are interested in finding average depth of rotation because we have to find the volume of rainfall. Okay, we have to find the volume of rainfall in the catchment area. This you should appreciate. So how I will find the total volume of rainfall that has occurred in our catchment area, total volume, how I will find? Sir, you know that in this rain gauge, sir, precipitation is different. In this rain gauge, different precipitation is there. Okay, in all the rain gauges, sir, we have different precipitation. So, sir, if I have to multiply the depth by area, okay, in order to obtain the volume, sir, which depth will I use? Okay, which depth will I use? Yes, perfect, Vishal. We have to estimate volume of rainfall. So for that estimation of rainfall, what I will do, I will multiply my catchment area. I will multiply my catchment area by average depth of precipitation. Yes or no? By average depth of precipitation, or simply I can say rainfall. So this average depth is very important. If I'm having certain rain gauges in a catchment area, then I have to find average depth, because that average depth is representing this depth here. Okay, you need to understand this P average, and this average depth is simply representing, you need to understand, we have converted our catchment area into a plane area of A. Okay, this is, let us say this is your area A, and how much depth it will store is none other than P average, or average depth of precipitation. Okay, so simply you can say that if I'm having certain rain gauges in our catchment area, then what is the average depth of precipitation with the help of which I can obtain volume of rainfall, that you can use here. Okay, so basically you can simply say to estimate volume of rainfall and runoff. Okay, to estimate volume of rainfall, what is this happening? Yes, to estimate volume of rainfall and runoff, average depth of precipitation is found out in the catchment area. See, I have written one more thing here, volume of runoff. Okay, you need to understand, if volume of rainfall is there, some portion of that rainfall will convert into runoff. Yes or no? Some portion of that rainfall will convert into runoff. I hope this is very clear to you. So obviously runoff thing, see, that we will discuss in the later chapter. So I hope the significance of P average is very clear to you, because with the help of this average depth, we can multiply it by catchment area in order to obtain the volume of volume of rainfall. Okay, so remember this formula. So sir, now tell me how to evaluate it. Okay, so now tell me sir, how to evaluate this volume of rainfall. Okay, and obviously this volume of rainfall will be in meter cube, hectare, meter. Okay, if this is in hectare, this is in meter, hectare, meter. Okay, like this we have different units. See, so volume of rainfall is very important. Basically, see, you need to understand that we have in rain gauges, what we measure in rain gauges, we obtain depth of rainfall. Yes or no? In pluviometer, ombrometer, hydrometer, or rain gauge, we obtain what? Sir, we obtain depth of rainfall. Yes or no? We obtain depth of rainfall. Perfect. Yes, if we'll deduct losses, then we'll get runoff. Great, Vishal. Perfect answer. Perfect. So good. Perfect. If you'll deduct the losses from this preparation, if you'll subtract losses, you will get the runoff. Now we'll discuss all the methods one by one. Okay, now we'll discuss one by one all the methods for estimating average depth of precipitation. So we have basically three methods. The very first one is we have three methods here. Okay. So the very first method which you can see here is arithmetic mean method. Okay, the very first method which we can see here is arithmetic mean method. See, this method is not used at all. Okay, this method you can say is not used at all. It is the least accurate one. Okay, least accurate one, which is not used at all. So if someone asks you, like, out of the three methods, which is least accurate and least reliable, what you will say then? Can you tell me? The method which is least accurate out of all the three methods, can you answer this simple objective question? That is your arithmetic. See, three methods we are going to discuss. The first one is arithmetical mean, then we have Thiessen polygon, and at last we have wait a second, at last we have isohydral method. Okay, three methods we are going to discuss, and one by one we are going to improve the method. Okay, most accurate method is the third one. So first method is the least accurate. Understood, sir? See, this topic is very important. Many questions have been framed. See, you can see in these slides many questions I have put up, so that everything is very clear to you. Okay, so be very attentive with me, so that all the concepts are very clear to you. So arithmetic mean method is suitable when, see, in two criteria it is very suitable. First, let me draw a catchment area here. first let me draw a catchment area here which has, let us say, 4 stations. The very first is P1, second one is P2, like this, so on so forth. We have, let us say, 4 rain gauges in our catchment area. Okay. Now if you want to simply evaluate average depth, okay, if you want to simply evaluate average depth, what you have to do in this method, you have to do nothing. You have to simply take arithmetic mean, nothing else. Simply take average, okay, simply take mean of all these precipitations. Understood, sir? So what is my formula? Sir, formula is P1 plus P2 plus P3 plus P4 and so on so forth, like that. Okay, like this you will get the answer. Simple, nothing else. Or simply, if I want, let us write like this. Let us write like this in general, okay, upon M. M is what? M is the number of working stations which are present here. Okay, so this is your basic formula which you have to remember. And if I want to write it in form of series, see, this bar is representing what? This bar is telling you average. Okay, so this P bar is giving you average. You can also write it like this: sigma. Sigma means summation of all the precipitations. Okay, I will vary from 1, 2, 3 like this. I will change from 1, then 2, then 3, till where? Till n or m, whatever value you want to take. Okay, if this is n, we will divide it by n. This is also the same formula, but it is written in series. Okay, so simply you have to do what? You have to sum up all the precipitation values and divide by n. This is your arithmetic mean method. But the most important thing, can you tell me when this method will be most suitable? Can you tell me? See, this method will be suitable only when we have plane area. Okay, sir, can you tell me that my catchment area will be plain or uneven? You tell me. Is the catchment area plain, perfectly plain or flat, or it is uneven, undulated, irregular? Can you tell me if your catchment area is plain or not? Everyone must be guessing it right. Yes, Vishal, you are correct that my catchment area will never be straight. Okay, it will not be plain. You can feel that this catchment area will be undulated every time. Yes or no? Never ever this happens that your catchment area is plain. Okay, this never happens. So, sir, if my catchment area is never plain, then obviously this is the least accurate method. Yes or no? Because this method is only suitable when your area is plain, but this doesn't happen, sir. This generally does not happen, because you can see that if you will pour some water at any place, it will automatically start moving because it has slope. Okay, it will start moving from one place to another. Yes or no? It will be uneven every time. Yes. So whenever my areas are very, very plain, then this will give you the good results. Then this method will give me good results. Understood, sir? Now the second point is that it is suitable when rain gauge distribution is uniform. What does this mean? See, meaning of this is that rain gauge distribution pattern. Okay, see, it should not be like this. That this is your catchment. Let us say we have 4 rain gauges. 3 rain gauges are placed or installed very close to each other. But the fourth one, sir, you have installed it at a very farther place or a remote place. So you can see that in this catchment area, sir, the distribution of rain gauge is not uniform. Yes or no? And also you can say 2 things are there. See, first thing, that distribution is not proper. See, some rain gauges are you have placed very near to each other, but some rain gauges are placed so far that they are not evenly distributed. Yes or no? Understood, sir? Now what is the second case? Also you need to understand rain gauge distribution pattern is uniform. It means that rain gauges are forming some pattern such that they are forming a pattern of a square, or they are forming a pattern of a triangle. Yes or no? So this is uniform pattern. Or let us say you have circular catchment area and all the rain gauges are placed at 90 degrees to each other like this. Yes or no? So this is also regular pattern. See, all these patterns which I have shown here are uniform. Yes or no? Because you can say, sir, this is the perfect kind of distribution. Because in this all the rain gauges are, you can say, equidistant to each other. Yes or no? Yes or no? Tell me. But practically, if I am going to tell you, practically, sir, this is not feasible. Just not feasible. Sir, practically, neither you will find plane areas and, sir, nor neither you will find plane areas, nor you will see that rain gauge distribution is uniform. So you will see that most of the times some rain gauges are placed near to each other. Okay, and you will see that distribution is non-uniform in nature. I hope this is very clear to you. Practically, both of these points are failing. Yes or no? Kindly comment. Practically, both of these methods or both these points are not getting fulfilled. Yes or no? Tell me yes or no, then I will proceed. So, sir, this method will give me the least accurate answers. See, it is saying it will give us the least accurate answer. Sir, why? Sir, because actually in practice, sir, no plane areas we will have, and rain gauge will be distributed in a non-uniform manner. Generally, it is you can say impractical method. Generally, it is a kind of impractical method. I hope this is very clear to you. Okay, that's why this is least accurate. Okay, simple. So, sir, now what we have to do? Now the thing is, sir, what we have to do now? Okay, sir, what I will do next? The next is one of the better methods. Okay, now we will try to improve these two drawbacks. Okay, we have two drawbacks here. These two we have to remove. Okay, so we will move on to your Thyssen polygon one. Wait a second. Yes. So we'll move on to the second method, which is you can say better than the first one. Okay, this method is for sure the better method, or you can say Thyssen polygon. Let me write in the bracket. It is better than arithmetic mean method, the very first one. Now, sir, what we do in this? How it is better, sir? Can you tell me how this method is better than the previous one? Okay, it is better than the arithmetic. It is better than the arithmetic mean method. But sir, how and why? Okay, both I want to know. Sir, why it is so? See, you can, if you will read out the points, see, this is also suitable for plane areas. Sir, the very first one, that was also suitable for plane areas. Sir, this is also suitable for plane areas. Sir, there is no difference. Sir, the arithmetic mean was also related to plane areas. Thyssen polygon is also related to plane areas. That means this method is also ignoring or is not taking care of the topography. It is not taking care of the topography. Yes or no? Tell me. So, sir, you are saying that this method is also not taking care of the topography, but you have to note down the third point. See, but it takes care of non-uniform distribution of rain gauge. If the distribution of rain gauge is not uniform, okay, which is generally the case, generally this is the case that most of the times you will see that rain gauge distribution is not uniform. So most of the times you will see that it is not most of the times you will see that rain gauge distribution is non-uniform. So this method is better because it will take care of that thing. It will take care of non-uniformity distribution of rain gauge. Okay, so it will take care of that. Sir, now the question arises, sir, how it will take care? How it will take care? So for that you have to understand this Thyssen polygon method. Okay, so for this you have to understand the entire method. It is a kind of procedure. We have to discuss that steps and we have to solve some questions. Okay, then you will be able to understand Thyssen polygon better. Okay, so I'm going to start the steps of yes, perfect. Yes, Vishal, you are absolutely correct. See, in this method, weighted average has taken. Weighted average has been taken. You are right. Weighted average has been taken. That's why it is the case that it takes non-uniform distribution of rain gauge into account and distributes it. Okay. So, sir, how it is taking care of non-uniform distribution of rain gauge? Can you tell me? So, if you want to understand that, first we have to understand Thyssen polygon method very closely. Okay. So, sir, tell me. So let us assume we have a catchment area. Okay, let us assume we have a catchment area here. Understood, sir? Let us take some rain gauges here. Let us say this is station A, B, C and D. Let us say we have, sir, 4 rain gauges installed in our catchment area. Okay, this is a huge catchment area. Let us say 10,000 hectare area. Huge catchment area, sir. 4 rain gauges are installed there. No problem, sir. 4 rain gauges are installed there. Now, sir, what I will do in this method, sir, what we do, tell that. Okay. So first step is the very first step. Let me write down the steps one by one. So the very first step is, if you want to find the average depth of precipitation using Thyssen polygon method, then we have to follow simple 3 steps. Okay, 3 steps we have to follow. So tell me those steps quickly so that I'm able to solve the questions which are generally there in the exams. Believe it or not, Thyssen polygon questions have been asked in recent years many a times. Okay, so please stay focused here so that these steps are very clear to you and you are not getting confused in it. Listen very carefully. Understood, sir. So the very first step is you have to join these stations. Okay, you have to join these stations using straight lines. So let me write down the very first point here. Join these stations. Join these stations using straight lines. Using straight lines to form to form non-overlapping triangles. Okay, sir, what is the meaning of non-overlapping triangles? See, first thing is that we have to join these stations. See, we have to join them using straight lines. Okay, we will not join them like this. Okay, see, we will not join them by curvy lines. We will join them by straight lines. Okay, so let me show you the very first step. See, we have to join this. Let me take whiting here. Okay, we have to join this. We have to join this. Okay, like this we will join. We will join this by this. Okay, like this we have to join it. I hope this is very, very clear to you how we will join. So, sir, what we have done here, simply what we have done here is, sir, we have joined stations using straight lines, yes or no, and formed triangles. But, sir, one thing is, see, listen very carefully here. Tell me, can you join this A and C? Can you join this A and C? No. Why? Sir, why I will not join A and C? Because when I will try to join A and C, it will intersect with this line. That's why I am saying non-overlapping. Okay. See, both we have two options. We can join BD or we can join AC. But we will not draw both of them so that triangles are non-overlapping. Okay. We will not draw this one. Yes or no? I hope this is very, very clear to you. Yes, Vishal. Okay. Great. You are paying full attention. It is great. Have you understood this first point? So what I'm trying to say here is that, let us say, sir, we have 4 stations. Sir, I will try to form triangles. Okay, see, this is triangle. But now when you will form triangle, you will not form triangle like this. Okay, because you need to understand, sir, when I'm forming triangle here and when I'm forming triangle here, it is overlapping. The sides are overlapping. The sides should never intersect. Okay, let me write here non-intersecting triangles. Okay, you can see that these triangles are overlapping. So how I will form the next triangle? Sir, I will form the next triangle like this only. Okay, I will form the next triangle like this only, or we will form the triangle like this. We have two options. We have two options, like this, like this. So we have done this one. Yes or no? Is this thing clear? Tell me first if this thing is clear. So tell me, if we have these 4, let us say we have a catchment area here, and these are your 4 stations. These are 4 stations. How you will join them? How you will join them? Sir, I will join them with straight lines to form triangles. Okay. Tell me, can you do like this? Can you do like this? Tell me, can you do like this or no? Can you do like this? Tell me, everyone kindly comment, can you do like this or not? Sir, I cannot do like this because you can see that edges are intersecting. Okay, edges of, I can do like this, no issues. Why? Sir, because these triangles are not intersecting with each other and I am saying these are separate. Okay, that's why I have written to form non-overlapping triangles. Okay, non-overlapping, or you can write non-intersecting here also. But yes, one thing you have to understand, if 5 rain gauges are there, then you will join like this. You will join like this. Okay, you will join them with the straight lines because we have a station here. Okay, when a station is there, then there is no problem. Let me write non-intersecting instead of non-overlapping. Okay, so the very first step I hope is very clear to you. I hope the first step is very clear to you. Yes or no? Okay, it's not clear. Wait a second. See, Vishal and Kiran, listen very carefully. Let us suppose we have, now tell me, let me give you the example. Let us say we have these 4 stations. You have to join them by straight lines and form triangles. So you will form a triangle like this. The second triangle which you have to form, you have to join stations. Yes sir, I will join stations like this. I will form triangles, but these triangles are not overlapping, so no problem. But you will not, listen here. First triangle sir you have formed. The second triangle which will form cannot be formed by joining these 2 stations. Why? Tell me. Why you cannot join these 2 stations? Tell me. Because it will intersect with the side of another triangle. This should never happen. If you are forming another triangle, sir, now if I am forming another triangle, sir, no side is cutting the first triangle side. Okay, no edge of the second triangle is cutting the edge of second triangle. It should never intersect. Yes or no? Okay, it is clear. Okay, it is clear. That's why. That is great. Now we'll move on to the second step. Sir, in second step, what we have to do? Sir, in second step, sir, what we have to do? We have to draw the perpendicular bisector on each side. Okay. See, can you tell me how many triangles are here? Sir, in this diagram, I can clearly see 2 triangles are here. 2 triangles are there. Simple, sir. And can you tell me how many sides are there? How many edges are there? Can you tell me? Yes, we have to make separate triangles. Can you tell me how many edges are there? Sir, 1, 2, 3, 4, 5. Sir, 5 edges of these 2 triangles are there in all. 5 sides are there total. Okay, one is common. One side is common. No problem. But sir, what I have to do now? I have to bisect each and every side. Sir, I have to draw perpendicular bisector on each and every side. This is the second step. Okay, perfect. So what I will do here is, first let me write down the step here. What I will do? Draw. We have to draw perpendicular bisector. We have to draw perpendicular bisectors on each side of triangle and extend them to form Thyssen polygons. Okay, that's the name Thyssen polygon. I will tell you how we form Thyssen polygons. To form Thyssen polygons. Okay, sir, how we do this? So listen very carefully here. See, we have to bisect all the sides. Okay, so this is the side. You have to bisect it. You will bisect it like this. Can you see this is the perpendicular line? Can you see it? You can clearly see that this green line is perpendicular bisector of this side. It is bisecting it into 2 halves. It is dividing it into 2 halves, and it is also perpendicular to it. Okay, this is perpendicular bisector of side AB. Now I am going to draw perpendicular bisector of side AD. Then I am going to draw perpendicular bisector of side BC. Okay, exactly perpendicular like this. And extend it also. Extend it beyond the catchment area. You have to extend them. Okay, perfect, sir. Now perpendicular bisector of CD is like, wait a second, it is wrong. It will be like this. Okay. Then we have to draw perpendicular bisector of BD. We have to draw perpendicular bisector of BD. It will be like this. Yes or no? This will be the perpendicular bisector of BD. You have to extend them. So all the perpendicular bisectors, sir, we have drawn here. Okay. Yes or no? We have drawn all the perpendicular bisectors. Now, how I will determine the Thiessen polygon? Now, sir, what is Thiessen polygon here? Can you tell this? So listen very carefully here. See this green line, or you can say, see, this green line is separating an area. See this entire area, which I am going to shade here, is this entire area. Okay, this entire area which this green line is separating or demarcating is for station A. Sir, this area is a Thiessen polygon for station A. Similarly, sir, this area is Thiessen polygon for station D. Similarly, sir, this area is Thiessen polygon for station C. And lastly, we have Thiessen polygon for station B. That means Thiessen polygon is drawn by extending the perpendicular bisectors. And at the end, sir, we can see that all the stations are allocated some area. All the stations are allocated some area which we have to find out. Okay, if these areas, sir, are irregular, listen very carefully, sir. If these areas are irregular, then what I have to do? See, if these areas are irregular, wait a second. This is for station B. This is for station D. See, I am showing with different shade. This I am showing with circle. Okay, this is your station. This is your Thiessen polygon for station D. Okay, so A, B, C, D Thiessen polygon are shown to you. Now, how I will measure the area of these Thiessen polygons? Okay, yes, area bounded by bisectors. You can say area which is demarcated by bisectors, and you can say the outermost line of your catchment area. The area enclosed by these two lines is none other than your Thiessen polygon area. Now, see, we have a contour map. Let me tell you, we have a contour map. At last, what I have to do? Now, the very third step and the last step is find out areas of Thiessen polygon. Okay, what you have to do now? Sir, what we have to do now? We have to find out areas of Thiessen polygon. We have to find out area of Thiessen polygon. Okay, we have to find out areas of Thiessen polygon and evaluate depth of average precipitation and find average depth of precipitation. Sir, how we will find the area of these Thiessen polygons? Can you tell this? And find average depth of precipitation. So how I will evaluate? Sir, how I will evaluate average depth area of these Thiessen polygons? So we have a map. Okay, we have a map, contour map. Basically, on that contour map we have a planimeter. Okay, we'll place planimeter, and in those planimeters, sir, we will simply measure this area. Okay, it's a method that you need not understand, but simply I can write one instrument here. The name of the instrument you can remember. Tell me the name of the instrument with the help of which we can find these irregular areas on contour map. Can you tell me the name of that meter? That is planimeter. Okay, so planimeter helps us in finding the area of these irregular figures. So if you want to find this area, this I will find with the help of planimeter. Okay, remember, planimeter determines basically determines what? Determines the area of let us say area of irregular Thiessen polygons. Okay, determines the area of irregular Thiessen polygons. But can you tell me, if we have regular Thiessen polygons, then how I will evaluate the area? Okay, see, if I have regular areas, let us imagine, let us say this is a regular area, triangle, or let us say we have a square, or let us say we have a rectangle, then how I will evaluate the areas that are symmetric? that we can solve with the help of basic geometry. Yes or no? Yes or no? Perfect. So regular areas or symmetric areas, sir, we can directly evaluate. Yes or no? In that, sir, there is no need to apply any logic. Okay, we can evaluate that simply using graph paper or basic geometry. Okay. Now, sir, what I will do with these areas? Let us say the area of A is AA and the rainfall which it has received is PA. So now what I will do? How I will evaluate the average rainfall? How I will evaluate the average rainfall? Sir, average rainfall will be evaluated by, see, first we have to put precipitation which is being observed by station A, then its Thiessen polygon area, then precipitation at station B multiplied by its Thiessen polygon area, then precipitation at station C multiply by its Thiessen polygon area, and so on so forth, like this, and so on so forth, divided by the total area, Thiessen polygon area of A, Thiessen polygon area of B, Thiessen polygon area of C, and so on so forth. Yes or no? Like this. So this is your, see what difference we have made here. See, if we will compare it with the very first method, arithmetic mean method, what is the difference? See, difference is simple. Only we have multiplied area. Okay, we have multiplied area here. See, if I want to write like this, if I want to write in series form, then what I have done, I have simply taken summation pi ai. I will start from 1 obviously, and it will go up to n. Okay, divided by total area, divided by our total area, starting from 1 to n. This is also the same formula. Yes or no? See, one thing you need to understand here, one thing you need to understand, if you are taking the first term PAA upon a total area, see, this is your area ratio. This is your area ratios. Then when you will write the second term AB upon total area, then when you will write the third term AC upon total area. Yes or no? So you need to understand here one thing. This AI upon total area thing, we can take it out. That is nothing but the weightage. Okay, that is nothing but the area weightage. See, if this station A is having more area, it will give more, it will get more weightage. If it has less area, it will get less weightage. If it has even less area, then it will get even less weightage. Okay, so simply area upon, see, this precipitation is multiplied by area upon total area. Second station precipitation is multiplied by its area upon total area. Yes or no? So sir, what you are saying here is, sir, you are simply multiplying. Okay, you are simply multiplying all the precipitations. You are simply multiplying all the precipitations by the area weightage. Okay, see, AI upon total AI upon total area. Okay, you are doing the sum of this. Yes or no? We are multiplying precipitation into area by total area. Every term is this only. Yes or no? So this is what? So this is weightage of area. Every precipitation is multiplied by its area weightage. Okay, this is area weightage. We can write like this also. We can write like this. Okay, this is what? Weightage. So more the area of Thiessen polygon, more the area of Thiessen polygon for any station, the more weightage it will have. The more that value will have weightage. Yes or no? That's why this method is sometimes also known as area weightage method. Okay, this method is sometimes also known as area weightage method. Yes or no? Sometimes this method is also known as area weightage method. I hope this is very, very clear to you. Okay, so all are the same. Simply because of this weightage of area thing, you need to understand, only because of this weightage of area thing, okay, the uneven distribution is finished. Even if the rain gauges are not distributed properly, they will get their respective amount of area. If it is non-uniform, some station, you need to understand, some stations will be very, very close to each other. If they are very, very close to each other, they will get less Thiessen polygon area correspondingly. And if they are uniformly distributed, you will see that they will get all of them will get equal share of areas. Okay, they will get equal share of areas, and obviously accordingly you will see that answer will be adjusted. So because of this weightage of area, you will see that it takes care of non-uniform distribution of rain gauge. Even if rain gauges even if rain gauges are distributed in random fashion or non-uniform fashion, then also it will take care of it, because it has taken, or if it you can say it has given weightage to your area. Okay, is this thing clear? Perfect. Now we'll solve one question with the help of which you will be able to understand it clearly. Okay, so remember these steps, these are very important. Okay, so this is a question which has been asked in your gate examination previously, gate 20 to 17 basically. So try to solve this. Okay, try to solve this, I will also help you. So tell me what answer you are getting here. So in this question it is saying we have a catchment area 25 by 25 kilometer square. Okay, and it has 5 rain gauges, one at each corner and at the center. So one is at the center, four are at the corner. As shown in the figure is not given to you. Let me wait a second, let me draw the figure here. Is it drawn? No, it is not drawn. No problem. Let me draw the figure here. Five rain gauges are there. Okay, 4 at each corner and one at the center exactly. Okay, so 4 stations are there, G1, G2, G3, G4, 5, and all the precipitation values are given to you. Okay, precipitation values are you can see given to us. Now what we have to do, if I want to find the average using Thiessen polygon method, what I have to do here, can you tell me? Sir, the very first step is, sir, we have to join them using straight lines. Yes or no? I've already told you this thing. First, what we have to do, we have to join them using straight lines. Yes or no? Yes, this G5 is at the center. Okay, this is 1, this is 2, this is 3, this is 4, this is the fifth one. Okay, sir. So simply join them by using straight lines. Sir, you have said that you have to join them using straight lines. So what I will do here is, wait a second. Yes, let us join them using straight lines. Okay. Yes, sir. You have to join them using straight lines. So we are using straight lines to join them. Okay. So we have formed triangles. Now we'll join this, we'll join this, we'll join this and this. So how many triangles we have basically formed? Sir, we have formed how many triangles? Sir, we have formed, simply you can see here, sir, we have formed how many triangles? Sir, basically 4 triangles. Okay, we'll join them with like this also, because obviously even if your catchment area is a square, then also you have to join those lines. Okay, so this is 25 kilometers. Okay, both the sides are 25 kilometer as the question is saying. Now, sir, in the second step, sir, what I have to do? In the second step, what I have to do is that I have to bisect all the lines. Okay, you can see here, sir, the second step is draw perpendicular bisector on each side. So, sir, 4 triangles we have. Total sides, if we count 1, 2, 3, 4, 5, 6, 7, 8. Total 8 sides we have. We have to bisect them. So, bisector of this 1, 5 side is this. Okay, this is the bisector of this side. Now, if you want to draw bisector of this side, this will be like this. Okay, this is the bisector of this side, and this is the bisector of this side. Yes or no? Simply when we will bisect this, we will get this. Okay, this is this green line is bisector of this 5, 3 line. Okay, then we have this line also, we have to bisect it. This will be the bisector. Okay, when we have to bisect this line, this yellow line, this will be the bisector. When we have to bisect this will be the bisector. When we have to bisect this will be the bisector. Like this, we have bisected all the 8 sides. After this, sir, you can easily see, after this, sir, we can easily see that this area which is demarcated by these extensions or perpendicular bisectors, station 1 is having this area as its Thiessen polygon. Yes or no? Station 4 is having this area as its Thiessen polygon. Yes or no? This is the Thiessen polygon for station 2, and this is the Thiessen polygon for station 3. Yes or no? And the area which is present in between, this entire area, is Thiessen polygon for station 5. Yes or no? We have to shade it. We will do like this. We will do here dotted shading. Okay. This is your entire area for station 5 because it is demarcated by your perpendicular bisectors. So now you can see we have formed Thiessen polygons for all the 5 stations. Yes or no? Is this thing very clear to you? Is this thing very clear to you? Perfect. Now you need to understand here how I will find these areas. Okay, see, you can easily find them. It is very simple. See, this is 25, so this is 12.5 and 12.5. So if you want to find area of a triangle which is 12.5, 12.5, you can simply do half into base into height. Yes or no? This is base, this is height. Simple. Half base into height you can easily do. Yes or no? Perfect. Okay, half base into height. So this is same area. See, if you will solve this, you will get it as I think you will get it as 78.125. Okay, this is 78.125. This is also same. This is also same. This is also same. All are the same. Take out the total area, subtract these 4 areas, and you will get the middle area. You can do this thing. Okay. Also, you need to understand, this is your this hypotenuse thing. This hypotenuse. Wait a second. This hypotenuse is nothing but 12.5 root 2. This is 12.5 root 2. This is 12.5 root 2. Multiply 12.5 root 2 by square it. You will get inside square area. One method is this one. Okay. Simply you can evaluate the areas. Second method is you can apply logic. Okay. Second method is you can apply the logic here. See, what is the logic here? Let us say this is your square. Okay. Let us say this is my square. So if this area, if this entire area is A, if you will half it, it will be A by 2. Yes or no? If you will half it, it will be A by 2, A by 2. If you will divide it into 4 halves, it will be A by 4, A by 4, A by 4. Yes or no? Tell me. All these area will be A by 4, A by 4, A by 4. Perfect, sir. Now when you will divide A by 4 part into even half part, okay, when you divide half, when you do half of A by 4, that will be A by 8. If you will divide A by 4 into half, that will be A by 8. A by 8, A by 8. That means this part is A by 8. This part is A by 8. Okay. This part area is A by 8. Total area is A, obviously, and this is also A by 8. Middle area is how much? See, this middle area is 4 times A by 8. Middle area is 4 times A by 8. So what I have to do here is, okay, middle area is 4 times A by 8. So what I have to do here is, yes or no? Middle area is 4 times A by 8. So it is A by 2. Yes or no? So this area is A by 2. So since the figure is symmetric, sir, since the figure is regular, it is not irregular. Sir, it is regular figure. That's why what I can say here is, that's why, sir, I can use, sir, I can use symmetrical properties. Yes or no? There is no need to find the entire area. Okay. But you can find it also. If you want to, if you are interested in finding this square area, you can find it. Find this hypotenuse, multiply them, you will get the square area. Okay. It is very simple. And I've also told you how to find the area of this triangle. Understood? So now, sir, you can say area 1, 2, 3 and 4. Okay. Sir, you are simply saying area 1, 2, 3 and 4 all are same and equal to 78.125 kilometer square if you are finding its magnitude, or you can say its magnitude is A by 8 if you are writing it in fraction of entire square area. Okay, and that fifth area is half of 625, which is 312.5, or a by 2. Okay. Now, sir, I will simply apply the Thiessen polygon area method. Then I will apply simply Thiessen polygon method, which is none other than P average is what? Sir, precipitation of 1 into first area, precipitation of 2 into second area, like this. Sir, we will multiply. Yes or no? And last we have is fifth one upon total area. Upon total, see a1, a2, a3, a4, if you will add them, it will be equal to a. Okay, we have already assumed that total area is a. Okay, you can write here. We can write here what is a. A is none other than your total area. Okay, you can also evaluate. You can write the magnitude also, or you can do like this. Now a1, a2, a3, a4 all are same. Take common. Okay, take it out. P1, P2, P3, P4 you have to add. Okay, you can understand that we can take a1, a2, a3, a4 common because all are one the same. You can write it a by 8 plus p5 into a by 2 because this area 5 is a by 2 divided by total area. Okay, this total area thing will get cancelled out. Now simply what I have to do, p1 plus p2 plus p3 is how much? So p1 is 300, 285, 272, 300, 285, 272, p4 is 290, 288, 290, and last one was 288. Okay, 288 divided by 2. This is 288 divided by 2 upon nothing, upon 1. Okay, so this is the final answer. I hope you can evaluate it. How much you are getting here? Can you tell me how much we are getting here? So P average we are getting here as, tell me, kindly comment everyone. 287.375. Perfect. Great. You are getting the correct answer here. 287.375 mm. I hope the answer is given in mm only. Yes. See, but one more thing. See, read very carefully the gate question, because in gate question they will give you the instruction like how you have to fill the answer. You have to fill the answer in mm up to 1 decimal place. Up to 1 decimal place. So can you tell me, if you will round it off to 1 decimal place, how much will be my answer? Round it off up to 1 decimal place. What will be the answer then? If you round it off to 1 decimal place, then my answer will be 287.37. You know this 7 is more than 5, so if you round it off to 1 decimal place, it will be 287.4. Yes or no? It will be 287.4. So you have to make sure that you are filling it in the correct way. Okay, otherwise answers will be wrong. So this is your solution to this gate question. So Thiessen polygon, I hope it is very, very clear to you. Okay, Thiessen polygon, I hope is very, very clear to you. Similarly, sir, you can see here one more question is there. Okay, one more question is here which you can see. Okay, can you find the answer to this one? Can you find the answer to this one? This is also a great question here. See, in this one, in this question, you can see we have been given a table. A table is given to us. In which first we have rain gauge number. Okay, you can see here, first we have rain gauge number. Secondly, sir, at all the rain gauges we have rainfall depth. I hope it is very, very clear to you. We have rain gauge depth, and at last we have area of Thiessen polygon. Okay, and at last we have area of Thiessen polygon in hectares. 10 power 4 meter square is hectare. You all know this. Okay, 10 power 4 meter square is hectare. So simply you have to do what? Sir, simply I have to apply the formula, nothing else. Simply apply this formula. Okay, simply apply P average. Simply what you have to do? P1 A1, P2 A2, P3 A3, P4 A4. Do this and get the answer. Okay. Tell me how much you are getting. Solve this. Solve this and tell me how much we are getting here. solve this and let me know what answer we are getting. So what we have to do simply is we have to multiply them this by this. So 470 into 95, 465 into 100, 435 into 98, 435 into 98, 525 into 80, 525 into 80, then 480 into 85, and at the last we have 310 into 92 divided by the total area. Divided by the total area, which is none other than 95 plus 100 plus 98 plus 80 plus 85 plus 92. How much you are getting here? How much you are getting here? You are saying it to be 445.636. Are you sure? 445 you are telling. Okay. Here we are getting it different. Let me check if you are right or not. Four 45.63. Yes, perfect. But we have to tell it to one decimal place, so it will be 445.6 mm. Yes, perfect. This is the answer. But I hope the unit is very clear to you, how we are getting this unit. Okay, I hope this unit thing is very clear to you. See, if we talk of numerator, in numerator, sir, we have multiplied this by this. So in numerator we have mm multiplied by 10 power 4 meter square. This is the unit of numerator. We have multiplied precipitation depth by area divided by area. Okay, in denominator we have this unit, area unit, so this will get cancelled. So obviously the answer which you will get is will be in mm. Okay, so I hope this unit thing is very clear to you. There is no need to convert anything here and there. Simply multiply them, divide it, area unit will get cancelled with the area unit, and you will get the answer in mm. Okay. Okay, now we'll move on to the next question. I hope this is very clear to you. So this question also has been asked in GATE examination. Okay. Yes, perfect. Now we'll move on to the next question. Okay, so this is a brilliant question with the help of which you will understand many concepts. Okay, this will give you more insight and more details. So we have a question here. You can see we have to find out the average depth of rainfall for catchment area of 200 kilometer square. Okay, we have a catchment area which is 200 kilometer square, a huge catchment area, using arithmetic mean and Thiessen polygon. See, we have to use both the methods. Okay, in this question it is saying use both the methods. Also find out the volume of rainwater that catchment receives using both methods. Okay, So first what we have to do, first we have to find out the average depth. First we have to find out the average depth. And in the second part, the question is saying we have to find out the volume of rainwater. Okay. In the second part, we have to find out the volume of rainwater. Okay. So what I will do here is, we have 8 stations basically. Or at all the 8 stations, we have rainfall data in mm. It's very clear. Thyssen polygon area is also given to you. See, there is no need of joining the stations and bisecting the sides. There is no need to do that. All the Thyssen polygon areas they have already drawn and simply given you the values directly. They have directly given you the values. There is no need for you to find it out. Okay, so what I will do here is, one more thing. At last, you can see a description is given. Okay, at last you can see a description is given in which O and I are written. See, this O and I means some stations are outside the catchment. Sir, what you are saying, that some stations are outside the catchment. O means outside. Let me write it here. O means outside the catchment, which means, listen very carefully. See, these 3 stations are 1, 2 and 8. First one, second one and 8th one are lying outside the catchment area, while 3, 4, 5, 6, 3, 4, 6 and 7. No. 1, 2, 5 and 8 are outside. 3, 4, 6 and 7 are inside. I stands for inside. Sir, will it make any difference? Sir, if some rain gauges are inside the catchment area and some rain gauges are outside the catchment area, sir, will it make any difference? Sir, will it make any difference? That I will tell you later, but first let us find the average depth of rainfall using both the methods. Okay, first let us find it out, then I will explain it to you, like will this outside and inside thing will make any difference or not. Okay, can you solve it? Can you solve it with the help of arithmetic mean first and then your Thyssen polygon method? So first we are going to solve it. First we are going to solve it using arithmetic mean method. Okay, everyone try to use your calculators and tell me the answer to the first one. So if I want to evaluate the mean, see, all the depths are given to you directly here. Okay, 40, 25, you can see here all the depths are directly given to us. So we will simply apply the average depth formula, summation pi upon n. N is 8 here. Okay, we have total 8 stations. So what are the values of depths which are given to us here? 40, 25, 37, 49. 40, 25, 37, 49. 37, 49. Then 55, 38, 48, 40. 55, 38, 48, 40. Tell me how much we are getting here. Can you tell me how much we are getting here? How much is the average depth of precipitation here? Can you tell me? Okay, Kiran is saying 41.5 by arithmetic method. Great. Great, Kiran. 41.5 mm is your average depth. Now, Kiran, also tell me what is the volume of rainfall, because initially I told you that if you want to find out volume of rainfall, you will multiply catchment area by average depth. I initially told you that when we have started this average depth concept, I initially told you that if you want to find the volume of rainfall, you will multiply this average depth of rainfall by catchment area. Yes or no? Yes or no, Kiran? So in our question, the catchment area is 200 kilometer square. Okay. Catchment area is 200 kilometer square. So the volume of rainfall you can easily find out. Volume of rainfall you can easily find out simply by multiplying this depth into catchment area. Okay, how much we are getting it? See, I think, Kiran, you are getting it wrong. Why? Listen very carefully. See, this is your this is in mm. See, we will multiply and find it out in meter cube. So first I will multiply this area. Area is 200 kilometer square. See, kilometer is 1000 meter. Square, if you will square it up, it will be 10 power 6 meter square. So it will be 10 power 6 meter square. I hope this area thing is very, very clear to you. 1 kilometer square is 10 power 6 meter square. You all know this. You all know this. This is area. Multiply by depth. Depth is what? Sir, wait a second. Depth is what? Depth is 41.5. Now 41.5 you have to divide by 1000, because in one, you all know that in 1 meter we have 100 centimeter or 1000 millimeters. Okay. So now you solve it. Now you solve it. These three zeros will get cancelled here. You will double it up. 83 will get. Okay, this is gone. 3 zeros are gone. 5 zeros are left. So you will get it as 8 lakh. No, 83 lakhs. Okay, or simply you can say 8350. 5 times 0. Are you getting this? Are you getting this? 83 and 5 times 0. Are you getting this volume of rainfall? Now I will use the second method in order to find, and I will also compare them. What is the difference in the answer that we are getting? I will compare them also. I will compare both the answers. Yes or no? Perfect. 83 into 10 power 5 is the correct answer. Now you have to solve this question using Thiessen polygon method. So for Thiessen polygons, sir, these are the depths of rainfall and these are the areas which are given to us. Yes or no? These are the areas which are given to us. So what I will do here is, in the second step, see, one thing is only not clear, otherwise all things are clear to us. What is that one thing which is not clear to us? That will that outside and inside thing, okay, if my catchment area is inside, is lying inside or outside, will it make any difference or not? Otherwise, simply you have to apply the Thiessen polygon method. Sir, should I consider the areas which are outside the catchment? Sir, should I consider the area of those rain gauges which are lying outside? Should I consider it or not? Yes, you have to consider it. I will explain the concept later. First, simply multiply this 40 into 7.2. First, simply apply the basic formula. You all know the basic formula is summation pi ai upon total area. Upon total area you have to use. Okay. So 40 into 7.2. 40 into 7.2, then 25 into 10.2, I guess, 25 into 10.4, then 37 into how much? 49.8, then 49 into how much? 49 into 35.8, then 55 into something, then 38 into something, then 48 into something, and at last we have 40 into something. Yes or no? So 55 into 6.6, 47.2, this is 6.6, this is 47.2, then at last we have 41.5, 1.5. Here we have 41.5, here we have 1.5. Okay, so this you have to solve, divided by total area. Total area there is no need to find, because when you will sum it up, you will get 200 kilometer square only, because in the question it is saying 200 kilometer square. Yes or no? When you will sum it up, you will automatically get it 200. So there is no need to solve it. Okay. There is no need of solving it. If you will add all these areas, 7.2, 10.4, if you will add all these areas, you will get it as 200 only. So I am directly writing 200. Okay. Or you can simply write 7.2, 10.4, all of them. All will sum up to 200 kilometer square only. Okay. So what is the value which you are getting here is? Can you tell me what is the value which we are getting here? After which we will find volume of rainfall. Can you tell me what is the value which we are getting here is? So Kiran is saying we are getting here it as 41.767. Are you sure? 40 into 7.2, then 25 into 10.4, then 37 into 49.8, then 49 into 35.8, 55 into 6.6, 38 into 47.2, 48 into 41.5, at last 40 into 1.5 divided by 200. 41.767 is the correct answer. Perfect. Multiply it. 41.767. More or less they are almost same. Now what is the volume of rainfall? You have to multiply catchment area. Catchment area is same, 200 kilometer square. Convert this kilometer square into meter square. You all know how to do it. Okay, I've already told you 1 kilometer square is equal to 10 power 6 or simply 10 lakh meter square. Depth is 41.767. If you want to convert mm into meters, divided by 1000. Yes or no? Divided by 1000. So how much we are getting here? If you will double this value, 5 zeros again, you will get this will be 83.4. Okay, 83.4 like, okay, yes, 8353400. Yes, 8353400. 83.5 into 10 power 5 like that. Okay, so you can see what is the difference here. You can see that arithmetic Thiessen polygon is giving you more answer, or you can say the more accurate answer, because it is accounting for the non-uniform distribution of rain gauge. So I hope with this example you can also compare them. But sir, at last tell me, okay, I hope till here everything is very clear to you. Kindly comment yes, then I will explain it to you what is the difference of outside and inside thing. Okay, you need to understand what is outside and what is inside. See, I will explain it on the next slide. Okay, or let me explain it here also. Okay, so try to imagine we have a catchment area. Okay, try to imagine we have a catchment area. Sir, some stations are coming inside, and let us say one rain gauge is coming outside. Okay, sir, some stations are falling inside and one of these stations are going outside. Okay, no problem sir, no problem sir. Some stations are outside, let us say some stations are inside, some are outside. So this is O, this is I. Okay, now sir, what I will do in this one, sir, I will join them using straight lines. Sir, you already told me we have to make triangles, yes or no? So sir, what I will do here, I will join them. Even if it is coming outside, no problem sir. Even if that station is coming outside, no problem, I will simply join them. I will simply join them sir. Perfect, join it, no problem sir. Simply form triangles. Okay sir, I have formed all the triangles. Now what I will do, I have to bisect all the sides. Okay, I have to bisect all the sides. So I will bisect this side, bisected sir. I will bisect this side, this is also bisected. Extend them, I will bisect this side, no problem. Okay, similarly you will bisect all the sides. Similarly you will bisect all the sides. Okay, similarly you will bisect all the sides. You understand this thing. Okay, bisect this, this is coming here. Okay, this is further extended. Like this you will bisect. So this is the area of this station, 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 this is the area of this station. Listen very carefully. See, the area, the rain gauge which is coming outside is having, the area which is coming outside is having a very less area. Yes or no? The area which is coming outside is having a very less share in the given catchment area. Why? Because it is going outside. If it will go further away, you will see, observe that it will have even less area. Yes or no? So the stations which are going outside, they will contribute, or you can say they are getting very less weightage in our catchment area. Why? Because they are having a very small catchment area here. Yes or no? Very small share of catchment area here. Yes or no? So you can see that those stations which are going outside, listen very carefully sir, those stations which are going outside, you can see the share of those Thiessen polygon area is very less, 7.2 only, 10.4 only. See here, 6.6, 1.5, 6.6, 1.5, 7.2, these are very less. as compared to your inside areas. Sir, inside areas you will see that they have more amount of share of the total area. 49.8, 35.8. See, these are bigger areas. Yes or no? Sir, we can see this. We can see here that the stations which are coming inside are having very big area. Yes or no? It is having a huge share. The Thyssen polygon area is having a huge share in the entire area. Okay, I hope this explanation is very clear to you, which means that even if the rain gauge is coming outside, listen very carefully, sir, even if the rain gauge is coming outside, no problem, sir, it will be accounted. But yes, its share, its Thyssen polygon area share will be very less when it will be compared to your total area. Okay, tell me if this thing is very clear to you. Tell me if this concept is clear to you. If station is outside also, then no problem. Then only thing is that it will contribute, the Thyssen polygon area contribution will be very less, and obviously this precipitation will be given less weightage. Why? Because its area share is less. Yes or no? So I hope with this explanation everything is clear to you. Okay, and now you are clearly able to distinguish between these two methods of finding average depth of precipitation, namely your arithmetic mean method and your Thyssen polygon method. Which is better? Obviously Thyssen polygon method is better. Okay, if you will compare them, Thyssen polygon method is better. Both are used for plane areas. Okay, this we have already understood. Okay, both are sir used for plane areas. This is also used for plane areas, sir. This is also used for plane areas, but sir, this one is for uniform distribution of rain gauge, but Thyssen polygon area will take care of non-uniform distribution of rain gauge by accounting for area weightage. Okay, yes or no? Tell me if all the points are very clear to you, then we will end our class, and the last method, isoatom method, we will discuss in the next class. Everyone kindly comment if all the points are very clear to you, then we'll end the session here. We have also solved many questions. Okay, try to solve previous year questions by now. Many questions have been framed till here. In 2023 examination also, Thyssen polygon question was there in both the sets. Okay, so it's important. So we'll discuss the third method, isometrical method, in the next class, which is the most accurate method. Okay, now this is the best one, and it will also take care of undulated and hilly areas. Okay, even if your area is not plain, then also that thing will be taken care of in isometrical method. Okay, so we'll discuss that later. Okay, perfect. I hope you have enjoyed the lecture and you have understood the entire concept. Okay, perfect. Now we'll part our ways and we'll catch up on Monday. Okay, because your classes are basically from Monday to Friday. But by this time, make sure that you have revised all these PPTs and notes. Okay, and you have also solved questions. Okay, try to solve engineering services question, engineering services previous year questions, and GATE previous year questions. Both of them you have to solve. Okay, try to solve as many questions as possible from hydrology. This will boost your confidence. Okay, is there anything which you want to ask? Then we'll end the session. Okay, let's end the session. We'll catch up in the next class, and whatever doubts you have, you can ask there. Okay, so thank you everyone. Stay blessed. Where is this thank you slide? Yes, thank you everyone. Stay blessed. Take care. We'll catch up on Monday. Till then, take care.